this video, let's discuss confidence intervals versus hypothesis testing. Essentially, what is the link between these two? So at this point, you should have a pretty good foundation of what a confidence interval is, what a hypothesis test is. We're going to talk about how they're similar and how they're different. So their similarities is they're both going to talk about and deal with the population proportion, because a lot of statistics is all about using samples to, in one way or another, find out more information about your population, such as your population parameter, so your population's proportion, your population's mean, stuff like that. So when we did confidence intervals, what we are doing is we're using them to estimate the population parameter. So we're trying to figure out and provide an interval to say, we are 95% confident that P or mu is inside this interval. So we make some sort of range and say, I believe my population's center, whether that be P or mu, is in this interval. Okay, and we slap, 95% confidence, 90% whatever. Okay, we're trying to estimate and say, I believe it's somewhere in between here. Hypothesis testing's slightly different. It's used to test a claim about the population parameter. So someone or something is going to claim that they know. We'll just use mu, for example. They'll claim, I think the population average is whatever, 17. Okay. What we're doing in a hypothesis test is we're kind of taking this claim about the population and determining, is it basically right or wrong? We can argue things like, I think the average is actually smaller than that. I think the average is higher. I just think the average is not actually equal to whatever you say it is. We could argue all those different things, okay? So you could argue, I believe, my true average is higher than what's supposed to be. My true average is supposed to be lower than what you claim it is, or it's just not equal to it. So this one, you're providing a range to say what you believe the population parameter is. A hypothesis test, someone's going to tell you what they think the population parameter is, and you're just going to be like, I think it's higher, lower, or just not equal to. So there's kind of some similarities and differences about there. So the connection between confidence intervals and hypothesis tests. What you'll find is you can really accomplish kind of a same task on both of these. A hypothesis test is a hypothesis test, but you could actually kind of use a confidence interval to really do the same thing as a hypothesis test is doing. So maybe someone makes a claim that the population average is 23, but your confidence interval, when you make it, it doesn't include 23, okay? Maybe it goes from 19 to 22. Then you're going to be like, well, if my confidence interval goes from 19 to 22 and you claim it's 23, then you're like, I don't believe you, okay? So you could kind of accomplish the same thing with both of these. One thing that a confidence interval will do is it's going to give you a range of numbers that they believe the population center is at. When you do a hypothesis test, and maybe you determine like, I think it's lower than 23. I don't know what it is exactly. I just know it's below 23, so it doesn't help you there. So if you're going to use a confidence interval alongside of a hypothesis test, there is a little bit of balancing that needs to take place, because confidence intervals, we have like 90, 95, 99%. Hypothesis testing, we have alphas of, 1%, 5%, 10%. So we need to talk about the link between the two. So let's first talk about a two-tail hypothesis test. A two-tail hypothesis test. So this is any time your alternative is all about saying, hey, things are not equal to each other, okay? So when you're looking at your approximately normal distribution, when you're saying not equal, that means you can either miss it by being too low or you can miss it by being too high. So if I were to say I have an alpha of, we'll just use 5%, 0.05. That's kind of the threshold for rejection. So I could either reject if we're down here, or I could reject if we're up here. So if we're at 5%, I need to equally split that. So that means there's 0.025 of our area down here and 0.025 of our area up above. So that's kind of the threshold area for are two-tailed hypothesis tests. So here's the connection, and here's kind of my logic that I get to make the connection between hypothesis testing and confidence intervals. If you have 0.025 in this tail and 0.025 in that tail, that leaves a proportion or an area left in the center. The area that would be left over is 0.95 because all this adds up to 1. So if 0.95 is left in the middle, that is 95%, which is a 95% confidence interval. So if you're going to do a two-tail hypothesis test, the equivalent in confidence intervals would be a 95% confidence interval. So you'll kind of notice these numbers just add up to 1. So if I did a two-tail hypothesis test and alpha is 0.10, 10%, my equivalent confidence interval would be 90%. Okay? The two-tail hypothesis is very easy to figure out what sort of confidence interval you need. It's the one-tail hypothesis test that takes a little bit of thinking, and kind of the logic I use to get the correct confidence interval, it might be a little bit shaky, but it helps me get the right answer. So a one-tail hypothesis test is anytime you're arguing that things are less than or greater than, less than or greater than. So let's say we're going to use an alpha equals 0.05, okay? And we'll just, for the sake of this one, we'll use the less than argument. The argument holds the same for a greater than. So if you're doing a hypothesis test and you're trying to prove with your alternative that things are less than some value at 5% cutoff, less than would be this area over here. And what that means is this 0.05 is this entire area over here. That entire area over there is 5%. So the logic I use to try and get us to the confidence area equivalent is I would really like this to look like my two-tailed test. You know, when I had both ends, you just find the area in the middle, you get your confidence interval. So I kind of construct this the same way. I would love to have two tails instead of one. So if this tail is 5%, let's make another tail that is also 5%. So what does that leave in the middle? That leaves 0.90, which is 90% confidence interval, okay? So if you're doing a one-tail test at an alpha of 5%, you're going to use a confidence interval of 90%. And these would have the same results. So a one-tail test of alpha of 0.5 gets you a 90% confidence interval. So kind of the trick there is for one-tail tests only, double your alpha and subtract from 1, and that will get your confidence interval. So if I would have done an alpha of 1.0 and I'm still doing a one-tail test, well, if you double that alpha, that gets you to 0.20, so then you would need 0.8, you know, so you'd have like 0.10, 0.10, 80 in the middle. So a one-tail test with an alpha of 0.10 would be an 80% confidence interval, okay? That's kind of the logic I use to get there, but again, that's just the connection between confidence intervals and hypothesis testing.